essentially, the magic that we see is happening because of statistics and mathematics.
Okay.
And it is designed to bring out the most logical outcome that you're asking it. Okay, so since this is one of the first episodes, so we'll start with understanding first of all what is intelligence, and then we'll see how AI works.
Okay.
So if we keep it very simple, intelligence compromises of two things. One is the ability to learn new things.
Yes.
And second is to then have logical, contextual, let's say, argument or conversation. How did we get to artificial intelligence? So without going into a lot of detail, obviously there was, over the last few years, there was a lot of effort in terms of machine learning. Because again, that is the first component of intelligence is learning, your ability to learn new things.
Yes.
And then of course, towards the end of that, getting into an area where, you can take all that information and have a logical conversation. Now, as we can see with the latest models that we're using in AI, some of it is really, really impressive.
Yeah.
Especially with the speed with which it responds.
Yes.
And usually, there's a lot of logic and clarity
Yes.
In the responses. And this is where it gets interesting, because if we look at the latest, Nvidia GPU, which is roughly the size of a postage stamp.
Yes.
So that has about 208 billion transistors just on one chip.
Yes.
And the reason that is required is, the communication that we're having with the machine.
Yeah.
At some point, it needs to go through a complete process where, it is processed and a logical answer comes back. So if we look at the layers of it, obviously starting with the human layer,
Yes.
it is the language that we, communicate with it.
Yes.
Whether it's English or whatever language you're using.
Yeah.
Since computers do not understand any language, they convert it into numbers, because eventually, remember, it's got to go to some transistors which are going to have an on-off state.
Okay.
And so millions of transistors, sometimes billions, are going to be switching on and off to get some kind of a result, which is a yes or a no or a logical answer.
Okay.
Okay, so that is where the kind of conversion happens. And so what happens is, whenever we ask it any question, the step one is it takes all of those words,
Yeah.
and it breaks it down. Every word is converted into tokens.
Yeah.
Okay, and then tokens are further converted. So essentially, what it is doing, it is taking our speech,
Yes.
and converting it into numbers.
Yeah.
So if there was a way to actually see what is going on, inside the machines,
Yeah.
is you can imagine these as like suspended sets of numbers, and we call them vectors. The reason that we call them vectors is because if you plot numbers on a graph, it's got a direction as well.
Okay.
Because if you just put numbers out there, it becomes very difficult to handle these numbers unless you convert them to vectors, because then it's easier to sort of treat them like objects. So so you will have corners of vectors in a big room, where the similar kind of words are going to be together.
Uh-huh.
So
it's basically,
yeah.
from what I understand, it's making sets of different things.
Yes.
And then it's recognizing patterns, I guess, from the question that you're asking it, or from the prompt that you're giving it, and then that's what is helping it to come up with the result.
Absolutely. So for example, if we said, do you like to have hot coffee on a warm day, or would you like to have cold coffee on a warm day?
Uh-huh.
Now, but this is a question that we can understand instantly.
Yes.
But when it goes to the machines, it's going to go through a process of, it'll have to figure out that the first warm is related to the coffee.
Okay.
And the second, hot is related to the day.
Uh-huh.
So it'll go off in those directions, and then basically go into a big, let's say, into a huge hall, into a big room, and it'll go into the coffee place, and it'll look at It'll have latte and cappuccino, all kinds of things around it, and it'll have warm coffee, and it'll also have cold coffee, right? So what the way it actually happens at a mathematical level is because these are numbers.
Yeah.
These are not actually words that the computer understands. There's a lot of multiplication and statistical formulas that happen essentially to figure out, what is the most likely logical response that the computer needs to give to you.
Okay.
Right?
There is something very interesting that I noticed when I was
Yeah.
using AI. It's that if I talk to it just like a computer, it doesn't respond really well. But if I talk to
Right.
it like a human being,
Yeah.
then the responses improve.
Yes.
So this is something very interesting. Maybe because the data that it's being trained on
Yes.
is all
No, absolutely. So so essentially, the way it determines the most likely answer is it looks at the weights of things. And when we say the weight of thing, we're saying what is the product of multiplication. It compares the weights and it takes the optimal weight or the shortest distance between two places. And so it says, okay, this is warm coffee. Or, it is talking, if it is talking about cappuccino, it is talking about coffee, and it is talking about, possibly beans. It sounds obviously a little difficult and confusing, but that is because, we're talking about converting speech, into vectors and numbers, and, then there's a lot of statistical things that are happening in the background, and it picks up the most likely and the most logical outcome that should be there in that context, and then it comes back with a response. So while all of these mathematical things are happening, because remember these are numbers now. So let's suppose, just to keep it a very, very simple, let's suppose, it has a weight of, if it has a weight of 12,
yeah.
then, we get an answer of yes. So 2 times 6 is 12. But because at the very end, the transistors are just going on and off, they just understand binary numbers. So the 2 will need to be converted into a number of zeros and ones, and the 6 similarly, and that will be multiplied. So, those sort of on-off things are happening at a binary level, because that is just an on-off thing, and there are AND gates, and, when we go into details on that. And then there's multiplication of matrices. So essentially, the magic that we see is happening because of statistics and mathematics.
Okay.
And it is designed to bring out the most logical outcome that you're asking it.
Okay. So do you think that AI is completely objective?
Maximally, yes. Maximally, yes. But again, it's a different discussion that we'll go on. We know that there is obviously manipulation that happens. So in all these parameters and weights that are applied to AI, there is manipulation that happens. So, without manipulation, yes, it will try to be objective.
Okay. I think if the AI is completely objective, I think this is very useful
Right.
for in the long run, because then it can build on existing knowledge
Yes.
exponentially
Right.
using reasoning
Yes.
and objectivity.
Yes. Yes.
And then it can come up with very profound discoveries or
Yeah, I mean, this is a good discussion which is actually happening because at the one end, Elon Musk at least he claims or he says that it's very important for AIs to be designed for maximal truth. They should be maximal truth seeking, so they shouldn't be biased.
yeah.
But I think that's just still up in the air because in reality, what we see is we do see manipulation happening in certain areas, or on certain subjects.